I tend to be drawn to those topics that are most challenging and those diseases that are most dramatic.
Gliomas are extremely aggressive cancers. It's right this way. They typically kill a patient in less than 1 to 2 years.
The strong desire to help these patients motivated me to think into completely new directions. How are these cancers so successful in colonizing the entire brain?
Understanding the neuroscience of these diseases is absolutely essential.
I was born in Hamburg in 1971. I decided apparently from very early on that I want to become a doctor. My pediatrician was a tall guy with a very deep voice and full of competence and care. I just wanted to become someone like him.
I was born in 1976. I grew up in the San Francisco Bay Area. I was always, as far as I can remember, interested in medicine, in science, and generally in kind of helping fields. I had a very close friend in kindergarten. His father was a pediatric oncologist. And I remember my mother said to me, "Look what he does. He is a doctor who takes care of children with cancer. He has the most important job there is." And I remember thinking, oh, well, if that's the most important job, maybe that's something I should do.
I am the first in the direct line in our family who has become an academic. But it's not so easy when you are not coming from an academic background. You're not understanding the codes of academia so well. I remember my principal in high school. He said, "Frank, I will suggest you to become one of the highest scholarships in Germany." I asked him, "That's fantastic, but what is that?" And he said, "What? You are telling me you're not even knowing what it is?"
All right, let's try a nice, straightforward one.
Okay. I come from a relatively non-academic family. When I was in high school, having just absolutely loved everything about science up to that point, I took honors biology in high school, and the first test didn't go very well. And I approached the teacher, and he looked at me and kind of pat me on the arm and said, "Oh, sweetheart, it's a rare woman who has a mind for science. Don't worry about it." I believed him, which I'm not proud to say. I was thinking that I just wasn't smart enough to do well in his class, in biology, in science in general.
I went to medical school. I went abroad to Queen Square, National Hospital for Neurology and Neurosurgery in London, which is a gem of neurology.
We have this pacemaker like so, which is
Very academic, wise professors.
fantastico. And you have unlimited amount of tissue, right? You see neurons there? You should videotape this. This is fantastic. Crazy shit.
I met Dr. Blau in London. He was the private consultant of the royal family. And Dr. Blau told great quotes. I remember one of them was, "Always listen to the patient. The patient always tells the truth."
Dir geht's ganz gut, das ist ja schon mal gut.
And it took me many years to understand what he meant. But when you really start listening to what patients describe, it not just tells you a lot about the person, it also tells you a lot about the disease.
Vielen Dank, wie gesagt.
Natürlich.
This is kind of a nice drawing of a cell. When I started college, I was incredibly fortunate to be assigned to Kate Sussman, who was a professor of biology and a neuroscientist. And I remember sitting in her office and she was looking at my high school transcript, and I actually did very well in all of my other science classes. She said, "What happened in biology?" And I said, "Well, I think I just don't have a mind for science." And she said, "Well, you had a really bad teacher, and we are good here, and I am going to fix this. So sign up for my biology class." And I ended up majoring in biology and was accepted to Stanford Medical School, and it really felt like a dream come true. And then it goes back to the heart, and your heart delivers the oxygenated blood. Mama. Isn't that cool?
When I decided to focus on brain tumor research, on neuro-oncology, and caring for people affected by brain tumors, I found it so devastating that the disease is really spread in the entire brain already at the time of diagnosis. This motivated me strongly to think into completely new directions. My hope was that I might be able to really make a true difference for the patients.
I remember seeing this first patient who had diffuse intrinsic pontine glioma, or DIPG. This is the leading cause of cancer-related death in children, fatal typically in less than a year, and it typically strikes children ages 6 to 8. And I had just never seen anything that awful. You know, it is a disease that is almost unimaginable. It takes everything from them except their consciousness of what's happening. Okay, let me try again. And at the time, we knew absolutely nothing about this cancer, and we had absolutely no way to treat it. And I remember sitting in clinic with a wonderful pediatric neuro-oncologist, Dr. Paul Fisher, and he said to me, "If you tell me the age of the patient, I will tell you where the glioma is." And I remember thinking, that is such an important clue. You know, I have to study this. I have to approach this from a neuroscience perspective.
Traditionally, brain tumors were seen as just some cells damaging the brain, but it's not communicating with the brain. Having cared for hundreds and thousands of these patients personally,
Guten Tag, hallo.
it's not textbook knowledge that you have, but you have engrams or patterns of disease progression. And I think all this helps a lot to focus on the important questions to ask.
And just look over here. There's just such a powerful synergy in both seeing patients and doing research. The patients really inspire the questions to ask in the laboratory. It motivates the work in the laboratory. I'm working to find solutions to problems that otherwise seem intractable.
We discovered that the cancer cells from particularly malignant brain tumors hijack neurodevelopmental mechanisms to really colonize the brain and make tumor cells thrive. My whole perception of what the nervous system can do was really enriched and widened by these discoveries.
I was advised that studying DIPG would be, quote, scientific suicide. And the reason was that at the time, there were no model systems with which to study them. One of the benefits of that event with my high school biology teacher is that I never listened to anybody again when they told me that I couldn't do something. Superman! One of the patients that I took care of was a child with DIPG, a 5-year-old boy, and his family asked me if they could donate his tumor at the time of his passing. From that tumor tissue, I was able to establish the first culture of a diffuse intrinsic pontine glioma. And so now we had a way to study the tumors. I realized that gliomas were forming actual structural and electrophysiologically functional synapses with neurons, that this biology was promoting their growth, their invasion, their resistance to therapy.
The discovery of Neuron-to-Cancer synapses was really an extremely important discovery for the entire field of cancer neuroscience and pushed the field forward. It bears the promise to really erect a new pillar of cancer therapy in the future for my patients and for our patients.
I think the future is bright for cancer neuroscience. I think that there is so much biology to be uncovered about the way that the nervous system regulates cancer that will be incredibly important for ultimately developing effective new neuroscience-inspired therapies for cancer patients. My advice to Michelle of 2 or 3 years old, I would have told her to stick with it. There's a lot of good that you can do for the world. You should continue on your path towards science.
If I could talk to little Frank, age 2, I would say, well, Frank, you might not remember this because your explicit memory starts later, but your... This is a very neurologist answer, sorry. Your impression that being a doctor is great is correct. Your impression that you really want to change something and provide help to other people is an excellent approach to life. That's what you should do.
Vielen Dank, das ist sehr schön. Mach es gut, ne? Wiederschauen. Tschüss.